another data management framework, which is called Flink. Okay, so recording. Okay. All right, so we'll start with Flink. So Flink is just another tool, but it's basically another system, another framework that we use to handle data. So it's just an open source stream processing framework, which is designed for high performance and stream processing application. Okay, so basically when we dealing with data, remember we said we can have a high amount of data. This is the reason why we call it big data, because we're dealing with a big volume of data. So now dealing with big volume of data, it can always be challenging in terms of how we process those data. So we need to have all these frameworks in order to manage this data. Okay, so basically when we look, think about it, when you let's say for example you are trying to you have a certain task to accomplish, right? So if you have a task to do, for example, you are the manager in a certain company. So I'm trying to kind of describe it. So if you are, for example, a manager in a company, and then you have a task, you don't even need to be a manager. You can just be anyone in the company. You have a task to accomplish there. So if you have to do it on your own, you may take more time. But again, if you have to do it with a team, let's say you have a full team to do something. Okay. Okay, so you are here, for example, you have this is a team leader here. You can call it team leader. You have a task to accomplish. So if you have to process, let's say, for example, you're dealing with 100 files of data. These are maybe people's information. So there is about 100 of them. So if you have to do it yourself, the only way you can do it, to do it properly, you have to do, maybe you do the first one. When you're done, you take the second one. You're done, you do the third one, and then the fourth one. So it takes a lot of time. But if you have to employ a team, let's say you have a team of 10 people. So this team of 10 people, you can easily say for the first group of people, they will handle 10 files. The other one will handle 10 files, and you guys can be able to complete the work in a short time. So when we look in big data, you have frameworks such as Flink. So what happens with Flink is that Flink will help you stream the data. So it helps you. So when we're talking about streaming the data, we're talking about moving the data from one place to another place. So we create so this framework will be between the source of certain data to the destination of the data. So an example I can give you, when you look, let's say you want to send a video, I will just ask that to the class today. Let's say you have files on your computer. you have 100 files in a folder. So those files can be files about anything. So if you want to email it to someone, can anyone tell us what they would do if they want to email those files? And make sure it's not too heavy. If they want to email it, someone asks you to email you those files. What will you do? Anyone? Can unmute yourself and tell us what will you do? Anyone? Anyone want to tell us what you will do? If you have 100 files in a certain folder on your computer, you want to email it to someone, what will you do?
You can compress and then you attach.
Yeah. So that's exactly what the software that you are using, which is compressing, will do. The software that you are using, whatever the software is created for, it will take all those files. When you compress them, it reduces the the size of the file into that folder, and then you can send it. And then if the person has to decompress it the other side, you will see that the files will be heavier again. So this is a way just for you to understand how Flink works. So Flink is also a framework that does that with your files. So think of it as if it's compressing it. So it takes the files, send them into a different destination faster. Okay. So it has the architecture of Flink has many features that will help the process which we're going to talk about. So basically, Flink and that another thing with Flink compared to other big data frameworks is that Flink will work in real time. So when you have a processing of data, for some frameworks, they can easily process data after a certain time or historical data of some scenario. But with Flink, it processes data in real time. So Flink will help you process data in real time, which is very important in certain scenarios. Let's say, for example, you're dealing with fraud detection. Okay, so if you're dealing with fraud detection in any scenario, in any case, you want to have those information in real time. You don't want to test data, historical data. No, you want to have it in real time. Okay, so basically, Flink only supports real-time computing with both high throughput and exactly one semantic, but also provide batch processing. So when we talk about batch processing, what is the batch processing and real-time stream processing, as I've just mentioned that. So stream processing, when we talk about stream processing, we're talking about real time. So basically the data are being processed as they arrive. So you receive the data in real time, you process them. So this you find it, for example, you're dealing with I mentioned fraud detection, you're dealing with any other scenario. You have sensors. When you're driving your car, you want the car to get the information in real time. So in real time, when it detects something, it processes the information and do whatever it has to do. Okay, so you have a lot of applications. So basically, when you have a Flink, which is also created by the same company, Apache, so we can also call it Apache Flink, right? So when you have Apache Flink, this gives you a true streaming. That means real-time transfer of data. You have other applications such as Kafka Streams, which also is an event-driven app. You also have Spark, which we spoke about last week. But with Spark, we have what we called last week micro batching. So we're processing events in in batch, so which can be a problem for certain scenarios. But you need to understand with Flink, we have real-time processing. Okay, so I've also mentioned what is batch processing. So batch processing will be processing large amounts of data, but in a scheduled interval, not in real time. So that's the difference between batch data processing and stream processing. Okay, so that's what you need to understand about Flink. So basically, the key concept of Flink will be it has a continuous processing of streaming data, event time, and stateful stream processing and state snapshot. So okay, we're gonna talk about that. So we will have the concept of what we call a checkpoint. We have windows, we have time, and then we have state. So this is how Flink will work. So Flink will work with it's going to remember the time when something happened, get the concept of the window, and that we're going to mention this. But most important thing for you to note is that this Flink framework will help you process the data in real time. Okay, so thinking of so the biggest difference between Flink and other stream engines is the state management. Okay, so the state management is one of the most important things when we have to compare Flink to other frameworks. So what is the state management? So it's basically um, uh, it's basically the fact that with Flink you have the way the stream of data are happening. You have a state, so you keep the state. So what does it mean? You keeping the state. It means at each level of the event when the data is being processed, the system is recording what was the state of that data. Okay, so it basically stores information about those data at each level. So so this is a core feature of Flink, the state management. Okay, so this will allow all the applications to just remember and process the data across different events. Okay, so in some, I'll give you an example. Which scenario, for example, where this feature is very important. Let's say, for example, your system has to count how many users. Okay, so how many users are using the system, maybe in an hour, right? So with Flink, the way because the information, there's a state management, so there's a system, there's a feature that is remembering at what time. So it has the application will remember at what time a certain event happened. So which means that we can be able to count how many people are using the app per hour or per day, per week, or things like that. So that's the advantage of Flink. Okay. Okay. So this can also happen. Can also be used when we talking about different sessions. When people log into your system, people log into the app. We can see the activity, so the user activity. So we can see that okay, people always log in for 5 minutes and then they log out. Things like that. Okay. And Flink is also used when you are actually creating an AI tool in machine learning, because in machine learning, when we are using what we call online learning. When we talk about online training, when we talk about machine learning in AI, we're going to talk about it. So when you're training your robot, the robot needs to remember what happened. Like it needs to remember how it performed before, so it can correct the mistake. An example I can give you: training a robot to maybe move from your lounge to the bedroom. So when the robot is learning from the data, it first makes mistakes and then it's correcting those mistakes. So in order for it to correct the mistake, it needs to remember about the mistake. So when you look at that, in that processing of those data, we can use Flink as a tool for processing the data. So that Flink, because of the state management, Flink is going to be very useful in that. Okay. Any questions so far? Okay. Okay, so this is the overall architecture of Flink. So we basically have uh, uh, data that can come from a cloud, from any cluster, or from your local server data are coming, and then you have any you have the streaming there link, so you can have a stream processing, which is used with Flink, or you can have a different um, system that can use the batch processing if you want to use the batch processing, and then this can take you to any application you're trying to deal with. So we have another concept of data stream. So when we talk about the concept of data stream, so what is data stream? So in Flink we have what we call a data stream API. Okay, so this is just an abstraction for processing real-time data. So, for example, when you have your phone, you're trying to communicate with someone, right? You have the real-time data going, all the messages going, and so you look at you look at that. It's like when you're trying to communicate with someone, the idea that you're having now is based on what the person said before, and it's a full conversation. So every sentence you write depend on what the person will say. For example, you're trying to respond to the person. So how the data are streaming, that's how the data are working. So now when we talk about data stream, it just represents the streaming of data. Okay. But now when we look at it now, we have um, we always say that the data streams are infinite. They are unlimited. Why do we say they are unlimited? Because there is no start, there's no fixed start, no fixed end. All right. So we're dealing with data just based on the events, based on the operation that are happening. Okay. So this is what happen with the event. So you're not going to see where is the beginning, when is the end. So at each level, at any level of the whole process, you can ask the uh, the system to do any operation. So there's no beginning, there's no end for that. That's what we mean by data stream, the way data are being exchanged. Okay, so another concept will be the data space. I think we mentioned that as well last week. So um, so when we talk about data set programs in Flink, these are just programs that implement transformation on data sets. For example, we want to filter all our data, we want to map them, joining or grouping the data. So all these operations here are done in the data set. Okay, okay, so what will be a Flink program then? A Flink program, when we talk about a Flink program, we're talking about an application which is built using the Flink system. We can call it an application which is built to use the Flink API, which will help us analyze or uh, analyze data, streaming, and data. So basically, you can say you can analyze streaming and batch data. So we have in this Flink program, you need to remember what we said first, that uh, events are happening in real time. So as we're receiving data, we are processing data and sending the data to the destination. So how will that work? So we have different data sources, right? So the data will have data sources such as the data can come directly from our Hadoop distributed file system, or it can come from Kafka, or it can be any text or any source. And then the system, and then in Flink, we're going to transform those data. Remember, I gave you the example of you having files on your computer, which is the data source, and then the transformation will be for you to compress it. And someone gave the example of compressing the data before you can send them via email. And then we have the data sync. The data sync will be the destination of those data. Okay, so that's the same way it works. So we will transform the data, and then the sync is responsible for final data output. So we can send them back to HTFA, CAPTCHA, or text. Okay, so this is how the data flow works. So now, what can be the transformation? The transformation can be for the data to be mapped, or the data to be filtered, or to be put in a setting to join certain data and do any operation with those data. Okay, so when we talk about the data sync, you need to understand the data sync is where the result is going. So it can go into the database, it can go into another file, or go into another environment. Okay, so when we're talking about transformation, so we can map the data, we can filter the data, and those are the transformations. Okay, so in terms of linked data sources, when we're doing a batch processing, remember batch processing means that we are processing data on a schedule, in a schedule, right? So we're not really doing that in real time. So we can process that from HDFS or from our local file system, and the type of data we can have text, CSVs, every type of data, and then the type of system we can use. We can use GDBC, HBase, collection, but when it comes to streaming, these are the tools that we are using. Okay, so this is just an example of how Link is running. So we have a job manager and we have task manager here. So where we have, when the program comes from Link, so Link will take the data using the code that we're going to have, and then the job manager will deal with that, and then it can stream it into different task managers. Why? So that it can we can deal with this data. So talking about that, so we will, because we need to really reduce the processing time of data. And yeah. Sorry, anyone asking anything or saying something? Okay. All right. Yeah. So thinking of this is the way Flink will work. So we basically have the users that will submit a Flink program to the job client, and the job client can be any platform or any framework that is that is that is that where we collecting the data from, and then the job client will process, test, and optimize the program, then submit the program to the job manager, and then the job manager will submit the task to the task manager, and then from the task manager we will be receiving certain feedback. So based on what we were trying to do, and then it's gonna come back to the job manager, go back to the job client, and that's how the process works. Okay, so we've mentioned already how in the job client we have the job operator, where the data source data can come from a file or a socket or data, and then we have a transformation operator. Data are transformed, they are mapped, they are reduced. And then we have the sync operator, where the data will be sent to the final destination. Okay, so this is an example of how it's going to be, how the code will be. So this was done in Java programming language, okay, where the part of string here is it. So here, for example, we're going to stream this on this environment. So this is just a code. No need to memorize it. This is just to show you how uh, how easy it works when you are actually coding this, but you need to understand exactly what you are doing and for what reason. So this is an example. Okay. So here in this example here, so from the source we're collecting the name, the age of the person, right? And then in terms of transformation, what we're going to do, we're going to create a person. So a person will have the information that we get from the name and from the age. So these two information, the name and the age, will create a new variable, which is a person, right? And then in terms of destination, the data thing, in this case, we're going to have, we just want to print, we just want to display a sentence that says, we take the name of the person and use the age of the person. We can say maybe my name is so and so, and my age is uh, whatever information we have. Okay. So in Apache Flink, the data can be processed both in batch and stream processing, right? Can anybody tell us what's the difference between batch and stream processing? Anyone can tell us what's the difference between stream and
Yes,
batch processing?
batch is for processing big data and in real time. No, stream is for real time, and then batch is for processing big data. Try and compress it.
Yeah. Yeah, so batch processing will basically process the data, large data, but not really in real time, but it's processing it based on a certain schedule. Okay, but when you talk about stream processing, it means everything is happening in real time. Okay, um, and what is the data sync? What is data sync? When we talk about data sync, what do we refer?
It's the location where data is going.
Perfect, perfect. Okay, so the data sync is a destination of this. So we have a data source, we have a transformation process, and then the destination, which is where the data is going, will be considered as a data sync. So that can be a certain database. Okay. Yeah. All right. Okay. So when we talk about bounded stream and unbounded stream, it's mostly we refer to when we're talking about an unbounded stream is when we have only the start of the stream, which is defined, but we don't have an end of the stream defined. But when we're talking about a bounded stream is when we talk about a start and a end of the stream of the data. Okay, so that's the difference. So in the batch processing process, in the batch processing application, so uh, instead of defining a sliding or tumbling window, so what are sliding and tumbling windows? So when we talk about windows, so it's basically when a window, it means, let's say, for example, you have uh, 10,000 um, 10,000 pictures that you're dealing with. So when we talk about a window, is maybe a certain, it's like a slice. You cut a slice of those data. So you have a certain, most of the time when we talk about window, we're referring more to the time. So a time when certain events happen. So you want certain events to happen in a certain time. So let's say, for example, it took you 5 seconds for a download of something. So that is a window that it took. So the event took only 5 seconds. So that is the window of that process. Okay. So when we talk about window, you must understand it's the time when a certain event just happened. Okay. So now we can split them into different. Remember, we just mentioned what you call this. We just mentioned stream, where we can have unbounded stream, which means we know the start, we don't know the end, or we can have a bounded stream where we know the start and the end. So now, when we look at that now, we can split windows into those unbounded streams. Okay, in terms of the process of what's happening. So basically, instead of defining a sliding or tumbling window over data and producing results every time the window slides, a global window is defined with all records belong the same window. For example, a simple Flink program that counts visitors in a website every hour, grouped by region continuously, is as follows. So this is an example where we're trying to count the numbers of visitors per hour. So in this case, for example, this will be an unbounded. So we know when we start to count, but there's no end. It continuously counts. So this is, in this case, for example, we just have a global window. So in a global window, all data. So we're taking all the data. We just counting everything. There's no limit. But when we talk about either a tumbling window or a sliding window, so when we say a sliding window is when we have a fixed size, like overlapping. So we say, for example, this event must happen only for 5 seconds. So we're checking what's happening in 5 seconds. You understand? So if, let's say, for example, an example I can give you, all right. Remember when, for example, you placing your information on a certain form, they give you an OTP that goes to your phone as an SMS. And then they tell you, they give you time for you to take that code and put it on the registration, then you can log in. But if it takes too long, then it doesn't work. Is there anyone who knows what I'm talking about?
Yes,
Have you
sir.
encountered such a problem? You see, so that is the window that you were given. So you were given maybe a 10-minute window. So in the 10 minutes, if you do not register, that code resets, so it's not going to work anymore. It expires. So this is what we're talking about. So those data that you were given can only work in that window. So that's when we talk about terms like sliding window, tumbling window, and global window. So when we talk about the global window, it's usually we don't have an end for it. The global window can be, let's say you're filling up a form, you have your you put your password. Even if it takes long to click on submit, you can still click on it. So there's no window in which you have to respect. Unlike OTP, okay, so an OTP can be qualified as a sliding window. So they've already created a window for that. So your OTP can only work in that. So you have a fixed size of time to do certain things, right? All right. So this is an example again. If you know that the input data is bounded, you can implement batch processing using the following code. So in if case, for example, we have the end of time, and then we have the global window. So something can happen until a certain time. Okay. Flink batch processing model. So in the bottom layer, we have the stream processing engine. Remember, we say in Flink we have a state management. So in the state management, we keep the state of the data, the data at each time. We have as well the window. So the window will be when it has to happen, for how long, and whatever will trigger it if there is any event that needs to happen, and then that will happen. And then we have what we call checkpoints. So what are checkpoints? So checkpoints will also be certain events, certain criteria that we need to happen as well. And then we have the watermark. So watermarks are just some certain mechanisms that are used in Flink that will really handle events and time processing. So what's happening in this event, at what time, So those are the watermarks. So it's basically kind of a timestamp of when certain things happen. So but why do we need watermarks sometimes? It's just that sometimes certain events can happen in a different order, maybe because of the network. Because of the network, you get data. Let's say you submit certain data, uh, uh, but your application or your software needs to do a certain process based on the data it received. So if, for example, what example can I give you? All right. So you need 10,000 information about a certain picture. So your system maybe will capture different information about a picture from a scan from the hospital. And all those information need to come for the system to process them and be able to detect a certain disease. Now, if there's a delay in processing other data because of the network, for example, you're going to get the wrong result, right? So now, to avoid this type of things, that's when we have to use watermark, because the watermark is a mechanism that will save the timestamp at which the data was requested. So it knows how to classify the data and knows how to wait for certain data to arrive before going to the next process. Okay, so that's why we use watermark. Okay. All right. Okay, so in Flink we have the stream and batch processing, as we stated. So basically, the two sets of Flink mechanism correspond to their respective APIs: data stream API and dataset API. So when we're creating a Flink job, you cannot combine two sets of mechanisms to use all Flink function at the same time. So you need to choose: are you dealing with data that like you want to schedule certain information, you want to deal with data that already exists, or are you dealing with real time? Are you receiving the data as you're processing them or not? So you cannot use both mechanisms at the same time. You will need to choose which mechanism you're using. Okay, so it's very important. Okay. Yeah, I think I've mentioned in terms of the time. Each time is recorded. The event time will be the time when an event occurs. Ingestion time will be the time when an event arrives at the stream processing system, and then you have a processing time, which is the time an event is processed by the system. So every millisecond is recorded when the data are being processed. this will help with knowing how we can handle this data depending on what's the scenario. All right, so this is an example. We have a certain information about the data that came at 10:00:00 and then 1:30. So you can see the difference is about 1 second or something like that. So the content of this file will have all the information about at what time the event, what was the event time, the ingestion time, and the processing time. So all this information will be very important. Okay, so I think this will be all for today. Any questions, guys? Any questions? Guys, remember what I said, that the exam can be scheduled anytime from the end of next week. So basically, so next week is considered to be a week for preparing the exam. So the exam can be scheduled for end of next week or whenever they will schedule it. So that's what you need to know. So this means that you need to start going through the videos and preparing already. Okay, any questions? Any questions?
Is there any way we can get the recordings or the notes that you need to use besides the videos?
I'm still waiting for the updated notes, but I can send you another version, but I'm gonna save it on the cloud. The link, the cloud is on the WhatsApp group in the description. You will see there's a link there, but I will save it right now. And yeah, I think we can take it from there. Yeah, I can just save that, and then I will keep you updated. Yeah. Any other questions? Any other questions, guys? With big data has a lot of theory. Unlike AI, AI has more of demonstrations and yeah, but it's fine. Gonna get more interesting when we get to AI next week.
So,
Yeah.
do we have to write the exam on a day that you choose, or we can write, because some of us are writing exams?
Yes. Yeah. No one responded to my message again when I spoke about the exam. But I think I've only received, if I'm not mistaken, I've only received 2 messages telling me about your exam schedule. So I'm not sure about your exam schedule. But again, I have spoken. I've sent an email to just ask about the exam. But as I'm saying, they can schedule the exam anytime from the end of next week. Because if we complete big data today, they will consider that you had 1 week to prepare to write the exam. But the exam date will be fixed. I don't know if you get what I'm trying to say.
You're saying it will be fixed?
No, I'm saying that. I'm saying the exam date will be a fixed date for everyone.
Oh, okay.
Yeah, it's gonna be the same date as everyone. But if we do not know when you are writing the exam, we're not gonna know what's the solution. because if we say we postpone it, it's maybe somebody else's exam, and then so everyone needs to be accommodated. Or if we can even schedule 2 different dates for 2 different groups, we can do that.
Okay.
Yes, but we can only do that. Yes, we can only do that if we know what's the challenge, how many people are challenged, how many people are writing next week or the other week. That's the only way we can do that.
We can still send you our exam dates.
Yeah, I need to have an exam date so that we can have, maybe on the group, we can have a poll to see how many, each date we can choose for the exam.
Oh, okay. Thank you, sir.
Yeah, because I'm not going to be able to create a poll not knowing exactly what date.
Sir, is it possible for the exam to be on weekends?
Yes, possible.
Is it going to be online, or like do we have to go to a specific venue?
No, it's going to be online with your camera on, and the thing is, the platform of the exam is really is an advanced platform where it checks every motion you do on your screen. So basically, if you open the exam page, you cannot click anywhere on the computer until you're done with the exam, you submit the exam. So if, let's say, for example, you have a notification coming on your computer, and then you touch that notification, you will see in the exam it's going to tell you have 2 more attempts to click on anything else. And if you do it you do it again, it's going to kick you out and terminate your exam. So yeah. So the reason why they want everyone to write at the same time, it's for the purpose of the person who's gonna invigilate the exam, so they can easily check a group of people than having to check 2 people or 1 person. That's the thing. All right, guys. Think.
One more question, sir, unrelated.
Okay.
I remember seeing something in the original email about being paid per certification.
Yeah. Yes. You earn, I think, 1,000 rands per certification.
Okay.
Yeah. So let's say anyone who passed this exam, if I'm not mistaken, it should be 1,000. Yeah. The last time I checked, if you pass, for example, this exam, you earn 1,000 rands. So with the 3 exam, you earn yourself 3,000, and then for the competition, you earn the competition price as well.
Okay. Thank you so much, sir.
Guys, imagine getting paid for your own knowledge, right? It was gonna be nice if universities were doing that. Every exam you pass, you get paid. I think we will solve a lot of problems. All right, guys. I think we can just maybe turn on our camera so we can just take the attendance. I can see. I think it's some Kelo asking, how do we claim the? Yeah, you have to pass the exam first. When you pass the exam, it's recorded on the system. Pass the exam. We know everyone who's in the class. After you pass the exam, then you'll be asked for banking details. All right, guys. Thank you very much. I will see you tomorrow.